Hi, I'm Eric Davis, and this is the deep dive into the Quick Connect system we have on the Davis connector. Now, I call it the dual action variable instrument system because, of course, we can have it on reciprocal tools, oscillating tools, rotating tools, and then, of course, we have fixed and free rotation through the annular grooves. But this deep dive is mostly about how we're going to take a look at it and see it. So what we do here is we have our C-clip wrench, and we're just going to take off the clip, the omega clip right here. Just pinch a little bit, comes right off. Use a magnetic work right here, and then I just let this go. And now you can see we have the aluminum sleeve. We also have the inner bearing, which holds these bearings in place. Here we have the spring that allows it to be actuated, and there we can see. So as you see, I'm letting them drop right out. Those are the bearings, and I want you to hear this. This one, you won't hear it very much. This one neither. And this one, just a little bit. That's the bearing that's going up and down in between that. It's normal. So if you're worried about whether or not this should sound like that, it should be okay. So it's more about this having the gap so that it can be done. And this inner ring is beveled on this side to, as it goes in to meet the detents around that, the annular detent, so that it can go over this. So aluminum lightweight sleeve, and that way that the power tool has less mass to go back and forth with, okay? Because we already have plenty of mass with the scrapers, and I'll tell you a little bit more about that in a minute. But we're alleviating some of the pressure off of that, and these bearings are sitting right inside the spindle. So you can see that this is one huge chunk of steel. It's 4140 or 42 CRMO alloy steel, and you can see that it requires a lot of machining. Perfect, precise machining for the bearings to fit in, perfect, precise machining so that the crenulations can fit without any problem, and that we have a seamless annular grooves when you choose to put it into the fixed or free rotation. Each groove is precisely made on these as well. Now, what you have to understand as well in this is that we have the power tool that is in fixed position. This end comes all the way up and butts up against the back end of the spindle, and therefore the only real shear strength is the backstroke where it's coming back like this. So on the power tool, it wants to break away. So that's why we went with a very large bearing here, because we had more shear strength on pushing and pulling even when it's in this position here. So one of the important things about this as well is that dry, clean. Do not put any oil on it. Try not to put anything that you think to lube it or anything. It's just going to attract the dust. It's going to attract all of the other stuff, and you want to clean up. The easiest way to clean this out is with a high pressure air gun or with a dry cloth. So it's easy to get back together. All you need is a little bit of your calipers and clips. And so in the case where you're trying to put it back together, you want to make sure that the beveled side of this goes down first. And then we're going to put the spring over the top. And all I do is I just set the bearing around the spring as it goes like this. And any one of them, like this one, where the spring is not holding it, that's the position that I'm going to keep it up in. But I can feel that the notch is down here. And in order for that notch to work, I want to make sure that I'm putting it back on with the notch in that place. And now, as I squeeze this back on over the top of this, I'm in the notch right here. And now I just hold it back. And here, I just bring in the clip and then separate it just enough, not too much. You don't want to be too aggressive with it. Bring it over the top, lock it in place, make sure it hits perfect, and there you can see the spindle working. Now, here we have what I described earlier. This is the free rotation. The bevel is obviously going down like this right now, but I'm not going to try to ruin my table. But here, free rotation, just like that. Pull the sleeve back, lock it into place, and now you're in fixed position. So just like anything that you would scrape. And then of course, as you know, the Tango 360. As you can see in this version, we were using some bluing in order to harden the steel and make it just right. So here we are in fixed position. And now we have of course, the press the button and we can be in either a 45, a 90, or 180 inline. And you can see now in a maximum setting, if I'm really pushing it, this is why the shear strength of those bearings were important. And you can see. So we have a soft start that lets it go from the Tango 360, and that allows it to really just kind of get up its speed without being too aggressive. And here I'm in free rotation position right now. I'm just going to pull it back, put it into free rotation, and I'm going to drop the speed a little bit just so it doesn't make too much. And then you can see here how we can Okay, so now you can see how the quick release adapter is both performance and why. Now, on the inside of the Tango 360, we have the this is a Scotch yoke mechanism, which is the rotation is here, and then of course it's going up and down like this. And in the damping handle, it is just fed. There's a nut, and then we have the spring, spherical bearing spring combination and it being held in. So I hope that helps you understand the Davis connector, its manufacturing process. It's a high-end, high-quality steel, and of course, only 5-axis CNC machines and really high precision 0.002 tolerance for most of the manufacturing process. So there you have it. Davis Tool Systems, spindle, and the Quick Connect system. Thank you.